Ask Claude to write you a phishing email, and it refuses. Ask it to explain how phishing works so you can defend against it, and it helps. That line, between what Claude will and won't do, isn't an accident. It was engineered deliberately into the model. In this series, we've gone inside Claude's architecture, its memory, and how it was trained. Today, the safety architecture, the system that decides what Claude should and shouldn't do. We'll cover why safety has to be built into the model instead of bolted on, how Anthropic encodes values through constitutional AI, how it draws the line between help and harm, the defenses that run every time you hit send, and the governance layer that decides whether a model is even safe to release. Start with the thing most people get wrong. A raw, pre-trained model has no values of its own. It is enormously capable and completely amoral. It will continue whatever text you give it, helpful or not. You cannot make a system like that safe by adding a list of banned words at the end. People route around filters in minutes, and real harm is almost never about a keyword. It's about context and intent. So Anthropic doesn't treat safety as a filter. It treats it as architecture. The guiding idea is defense in depth. Multiple independent layers, each designed to catch what the others miss, running from the training process all the way through to live deployment. No single layer is trusted to be perfect, because no single layer is. The base model's raw capability is the material you're working with. Safety is the structure you build into it and around it. And like any real structure, it's only as good as the way the layers hold together. Everything else in this video is one of those layers. The first layer goes in during training. After pre-training, the model can produce fluent text but has no stable sense of what it ought to do. Most labs shape that behavior with human feedback alone, people rating which response is better. Anthropic adds a second mechanism, constitutional AI. Instead of relying only on human raters, they give the model a written set of principles, a constitution, drawn from sources like the Universal Declaration of Human Rights alongside Anthropic's own guidelines. The model is then shown its own responses and asked to critique and revise them against those principles. It's trained on the improved, more aligned outputs. This is reinforcement learning from AI feedback. The advantages are real. The values are explicit and written down, not buried in the preferences of an anonymous rater pool. They're applied consistently at enormous scale, and they can be read, inspected, and argued about in public. The Constitution is why Claude tends to explain its refusals instead of just stonewalling, why it tries to be honest about uncertainty, why it weighs competing harms rather than pattern-matching forbidden words. But it isn't magic. A principle like be helpful and harmless still has to be interpreted across millions of edge cases the authors never imagined. The Constitution sets the values. It does not, by itself, resolve every conflict between them. Knowing that Claude has values doesn't tell you where the lines actually are. Someone has to decide concretely what counts as harmful enough to refuse. Anthropic publishes a usage policy and maintains an internal taxonomy of harms. Categories like child safety, weapons, large-scale cyber attacks, fraud, and more. For each, they define what's off-limits and what's acceptable. Here's what makes it genuinely hard. Most knowledge is dual use. The chemistry that explains a poison also explains the antidote. The code that probes a vulnerability is how you patch it. A system that refuses everything near a sensitive topic is useless. It fails the security researcher, the nurse, the journalist. A system that helps with anything is dangerous. So the line isn't drawn around topics, it's drawn around intent and uplift. Does this response meaningfully help someone cause serious harm they couldn't easily manage on their own? Over-refusal carries a real cost. A model that lectures you instead of answering a legitimate question. Under-refusal carries a worse one. Over time, Anthropic has tuned Claude to refuse less on benign requests, as the model gets better at telling the difference. The taxonomy is the map. But every map has contested borders, and this one gets redrawn as the world and the model keep changing. Everything so far happens during training, but the boundary also has to be enforced live, every single time you send a message. The first runtime layer is the system prompt, standing instructions that frame how Claude should behave inside a given product. Above that sit classifiers, separate models that watch inputs and outputs for known categories of harm, including specialized ones. Anthropic calls constitutional classifiers, built specifically to catch jailbreak attempts. Because this is an adversarial problem, people craft elaborate prompts, role plays, hypotheticals, encoded instructions to talk the model past its own training. Jailbreak resistance is the model's learned ability to hold its boundaries even when the prompt is engineered to erode them. No model is perfectly robust here. It's a permanent cat-and-mouse game. And behind all of it is monitoring, aggregate, privacy-preserving detection of misuse patterns at scale, which feeds back into the next round of training and the next update to the classifiers. Notice the shape of it. Training builds the values in. The system prompt and classifiers guard the perimeter at runtime. Monitoring watches the whole system and closes the loop. That is defense in depth in practice. The layers from earlier, each doing its job at the precise moment you press send. There's one more layer, and it sits above the model entirely. It's the question of whether a given model should be deployed at all. Anthropic's answer is the responsible scaling policy. It defines AI safety levels, tiers of capability tied to escalating safety requirements. As models grow more capable, especially in high-risk domains like bioweapons or autonomous cyber attacks, they have to clear harder evaluations before they can ship. If a model crosses a capability threshold without the matching safeguards in place, the policy says you don't release it. That's the governance layer, a public commitment, made in advance, that capability alone does not earn deployment. And for you as a builder, all of this is inherited. Every product built on top of Claude gets the constitution, the usage policy, the classifiers, the refusals, whether you want them or not. You can shape behavior at the edges with a system prompt. You cannot remove the base safety layer, and you shouldn't design as if you can. The practical takeaway is simple. Learn where the lines are before you build across them. The teams that succeed with Claude don't treat its safety architecture as friction to fight. They treat it as a property of the platform, the same way you'd respect the physics of any material you build with. That's the safety architecture, from the constitution baked into training to the policy that decides whatever ships. None of it is neutral, and all of it shapes what you can build. If this was useful, subscribe. Next, interpretability. How Anthropic tries to look inside the model and actually read what Claude is thinking.